Good morning, and today we're going to be speaking about the concept of the mole. It's not this cute furry animal on the screen, but rather it is a concept in chemistry, okay? It is a number. So, to start off the lesson, I want each individual to write down and explain what an atom is and what a molecule is. So I'm going to give you some time, write them down on a piece of paper, and then you can continue the video. So by now you should have written the definitions of the atom and the molecule. So the atom is the smallest particle that will still to be considered as the respective element. Okay, so this means that, for example, if you have a piece of gold, it is how many times you can break this piece of gold where you will still have this same particle, okay, this same element. Whereas a molecule can be defined as a unit that include two or more atoms that can come from different elements that are bonded together. Okay, so a molecule must include two or more atoms. They can come from either the same element or from different elements, but the important thing is that they are bonded together. Now, on that same piece of paper, we have 180 grams of sugar. Okay, we have 180 grams of sugar. And sugar is made up of sugar molecules. From now on, molecules and atoms, we're going to refer to them as particles. It's just a little bit easier, okay? So we don't have to define between the two. We'll refer to them as particles. So how many particles do you think are going to be present in 180 grams of sugar? Please note that particles are very small. So 180 grams of sugar is going to have a very big number. Again, on the same piece of paper, write down a number, and once you write it down and you're comfortable with that number, then you can come back and we'll continue with how many grams or how many particles are present in 180 grams of sugar. So the number of particles here is going to be 6 times 10 to the 23. So that would be 6 and 23 zeros. So it is this number, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So it's a huge number. And that is 6 times 10 to 23 particles of sugar. Now, I remember back when I was your age, we were like, but how big can that number be? And my teacher was like, more than there are sand particles in the universe. More than there are stars in the universe. And we were like, whoa. And this number is called the mole. Okay? And this number is called the mole. Okay? Now, the mole is very similar to a number that you might be used to. And you might be used to do the word dozen, which is equal to 12. Okay? So if we say dozen eggs, what we really mean is 12 eggs. And we've been using the word dozen since we probably were little kids. Okay? So by now, it's ingrained in your mind that whenever you hear the word dozen, you don't see it as a word, but rather we think of the number 12. The mole is something similar. It is a number. And for a chemist, this is a very, very important number. Okay? And we will be speaking about what this number does, what the mole does in the next lesson. Because there's a relationship between what we have done last semester with the relative atomic mass and the mole. Okay? So let's work a question using the term dozen. Now, when I was a kid, I used to go and play football. You can see it's a long, long time ago now. But we used to have these bags full of footballs. Okay? And in this bag, there were 36 balls in each bag. How many dozen balls were there? Can you please work this out for me? Again, work it out on the piece of paper that you have next to you, and then we're gonna see the working together. So I believe that at this point, most of you would have gotten to the answer 3 dozens. Some of you did not even need to do the working, but the working would go something like this. 1 dozen equals 12 balls. How many dozen equal 36 balls? And then it would go as 36 balls over 12 balls times 1, which is equal to 3 dozen. Okay, and this working is very important. Now, here, both in this example and when I spoke about the eggs, the term dozen has a fixed number. Okay, the term dozen has a fixed number, and it is the number 12. Okay, so whenever you hear the word dozen, it always goes to number 12. Same thing goes with the mole. When I said the mole is a number, okay, that means that the mole is a number that does not change. Okay, so it's called a fixed number. So 1 mole of copper, 1 mole of sodium atoms, 1 mole of carbon atoms, 1 mole of carbon dioxide molecules, 1 mole of dishes, 1 mole of sand particles, 1 mole of stars, they all correspond to the number of 6 times 10 to the 23. Okay, so 1 mole is a fixed number. Okay, so the same as what we have done with the dozen, we can use the same calculation and find the number of mole of particles. So for example, let's write an equation, let's write an example here. Okay, so let's say there are 12 times 10 to the 24 carbon atoms. How many moles of carbon atoms are there? Can you please try it out? Again, we're going to be using the same concept that we've done in the moles. Simple proportion. And I'm going to show you what we had done with the concept of the dozen with the footballs. Okay? So can you please try it out? So let's work this out now together. And after this, we're going to have another example. Okay? So here we're going to have 1 mole equals 6 times 10 to the 23. How many moles equals 12 times 10 to the 24? So for this one, because we're going to be using the powers, it's important to get used to using the calculator. Okay? Very, very important. Important to get used to using the calculator. So here you'll be having 12 times 10 to the 24 divided by 6 times 10 to the 23 times 1, which is equal to 20 moles. So the answer for you will be 20 moles. Okay? So let's work another one. And again, we're going to first have some time to work it out. And I will leave this one for you to consider, okay, and compare with. And then we'll work it out together. So, how many particles of water are present in 15 moles of water? Okay, so again, first we're gonna have the chance, okay? First we're gonna have the chance to actually try it out yourself, and then we'll work it out together. So in this question, we know how many moles we've got. We know how many particles we have in each mole. So 1 mole is equal to 6 times 10 to the 23 particles. Okay, 15 moles equals to how much? So it will be 15 times 6 times 10 to the 23 over 1, which is equal to 9 times 10 to the 24 particles. Okay, it's equal to 9 times 10 to the 24 particles of water. Now, today what we've done is that we have discussed the mole, the number, the mole. And that's what all it is. It is just a number. And to consolidate what we've learned, you're going to have a little bit of homework. Now, you can start this homework now, and you can pause the video, because the answers for this homework, okay, is going to take place in the video, okay? So I'm gonna stop, you can pause the video, work the questions. The questions are gonna be these ones here, okay? Work the questions, and then you can proceed with the answers to see if you got them right or wrong, okay? So pause the video, work the questions, and then continue to see the answers. So let's take a look at the answers here, okay? So again, don't panic if you get any of these wrong. Don't panic if you don't understand something. You can always send me messages and ask me. You can always try them again. You can always look at the video again. But most importantly, if there is a problem, always contact me. Reach out and I will try and help you the best as I can. So this beaker is filled with 2.5 moles of NaCl. How many particles of salt are in the beaker? So we know that NaCl is 1 particle. So we know that for question 1, we can write 1 mole equals 6 times 10 to the 23 particles. Okay, 2.5 moles equals how much? So this would be 2.5 times 6 times 10 to the 23 over 1 equals to 15 times 10 to the 23 particles. So that is question 1, and we're going to color code the answers. Question 2, okay, this beaker is filled with 1.76 times 10 to the 22 particles of sulfur. How many moles of sulfur are in the beaker? We have the same principle, but we're going to be using it from a different perspective. So now we know that, again, 1 mole equals to 6 times 10 to the 23 particles. And the question is, how many moles of sulfur particles are present? If you have 1.76 times 10 to the 22 particles. So this is going to be 1.76 times 10 to the 22 over 6 times 10 to the 23 times 1, which is equal to 0.0293 moles of sulfur. Okay? So the answer here is 0.0293 moles of sulfur. Now let's do question 3. There is 1.75 moles of salt dissolved in water. In this beaker, what happens to salt when it dissolves in water? So when salt dissolves in water, it dissolves. Okay, so NaCl solid, and it gives you Na plus aqueous plus Cl minus aqueous. If there's someone who forgot maybe this concept, again, please first revise your notes, but if you have any questions, please ask. Okay, then how many ions and moles are present? So the first thing to note here is that 1.75 moles of salt will give 3.5 moles of ions. Why? Because for every mole of NaCl, I get 1 mole of Na plus and 1 mole of Cl minus. And what this means is that for every mole of NaCl, I will get 2 mole of ions. Okay? And then we're going to continue as usual. Okay? So 1 mole equals 6 times 10 to the 23 particles. Or in this case, we can write them as ions because we have identified these particles to be ions. 3.5 moles equals how much? And the answer here would be 21 times 10 to the power of 23 ions. Okay? And the last one, the last question that we have for today, it was question number 4. Okay? I need 3.07 times 10 to the 23 atoms of copper to complete my experiment. In this beaker, I only found 0.25 moles. How many more moles of copper do I need? So first, the question, we need to find how many moles of copper we originally need. Okay? So we know that 1 mole equals 6 times 10 to the 23 atoms of copper. Okay? How many moles equals to 3.07 times 10 to the 23? And here we have 3 times 10, 3.07 times 10 to the 23 divided by 6 times 10 to the 23 times 1, which is equivalent to 0.512 moles of copper atoms. Now, originally I had 0.25 moles. So I need 0.512 moles. I already have 0.25 moles. Therefore, if we subtract, okay, we're going to have whatever we need. So we're going to need 0.262 moles of copper needed. Okay? We're going to need 0.262 moles of copper extra. Now, don't worry, if you've got any of these wrong, it's not the end of the world, okay? These were not the easiest of questions. So, again, go and take a look and see if you can understand them, you can work them out. And I will be giving you more work in the coming weeks, okay? In the next lesson, we're gonna correspond the mole to the mass of the atoms, okay? But it's gonna be for next lesson. And in fact, okay, to close off this lesson, I'm gonna show you a video. To close off this lesson, I'm gonna show you a video, okay, which will be a short summary of today's lesson, and it will also be an introduction to next lesson, okay? Enjoy, boys, and have a good time.
In this video, we're going to cover what the term mole means and see how we can use this formula to convert between moles, mass, and relative formula mass. Now, the term mole is a bit weird, but really it's just a unit we use to measure the amount of chemical that we have. So just like we measure distance in meters and time in seconds, we can measure how much substance we have in moles. And 1 mole of any substance is just the amount of that substance that contains 6.02 times 10 to the 23 particles, with particles referring to atoms, molecules, ions, or even electrons, depending on which substance you're talking about. So if we had a little pile of carbon, and we were told that it contained exactly 1 mole of carbon, then there must be 6.02 times 10 to the 23 atoms of carbon in that pile. We call this number Avogadro's constant. And the reason it's this specific number is that the mass of that many particles of any substance will be exactly the same number as that substance's relative atomic or formula mass in grams. So our little pile of 1 mole of carbon would weigh exactly 12 grams, because carbon's relative atomic mass is 12. Meanwhile, 1 mole of oxygen, which has the relative formula mass of 16 times 2, so 32, would weigh 32 grams. Or 1 mole of CO2, with a relative formula mass of 12 plus 16 plus 16, and so 44, would weigh 44 grams.
Okay.
But in all these cases, there would be 6.02 times 10 to the 23 atoms or molecules.
Now, before we close off today's lesson, the last thing I want to say is that the mole, the number we've called and we've used before, we can also name it as Avogadro's number. But for now, we're going to be referring to it as the mole, okay? For now, we're going to be referring to it as the mole. I'll see you for the next lesson. Hope you have a good day and take care.